laws and whatnot have the same exact looking graph with the same K slope, except that the axes are different when you linearize them.
Well, I mean, there's no reason to justify, or there's no reason to think about it like that. You look at the equation, right, and you figure out how this fits a linear, fits a line. So there's no reason to say, well, they all just have different axes, because then you're just trying to find a sort of shortcut in terms of explaining these graphs. These graphs come from these equations. And so that's how you want to remember it. You just don't want to say, well, they're kind of all the same, I just put different stuff on different axes. Then you're bound to mess something up.
Don't you have different axes and different slope as well?
The slope could, well, you've got, I mean, in this one, the slope is K, right? Because K is right there. In this one, you either have K or you have 2.3 over K. So, yeah, you know, you might be able to generalize it that the slope is K, but I don't think you want to go there, because then you're not really understanding where the plots are coming from. Yes?
So there's two different plots, like on this first order. I could plot rate as the y-axis and A as the x-axis, or I could plot log of AT as on my y-axis and time on my x-axis. I mean, depending on how you would ask the question.
Oh, yeah. So that's a good one. Yeah. You could always plot.
There's two different equations with two different plots that you could do for each one of them.
Yeah, you could always plot rate as a function of A0, right? You could always plot this rate. So, you know, the rate will increase, and you can actually get the slope of this line will give you the order, right? No. You would have to fit it. You'd have to fit it to that. Yeah. So you could always plot rate as a function of A0, because rate equals K times A, you know, A. So you could get.
So the slope would be like K.
Yeah, in this case it would be.
You know, go through 0 as the B, or as, yeah.
Well, this would be K, yeah, because the concentration of A.
And 0 would be where it intersects.
Mm-hmm. So you could plot it like this. We didn't talk about these rate versus concentration plots a lot, except for 0th order. So this one is very easy. The other ones we don't need to know about as much. Anything else? Yeah?
How can we figure out from the just chemical equation the rate number?
You can't. So the chemical equation will not give you the rate.
Coefficients?
Coefficients, none of that stuff gives you the rate. You need data. So you could have, you could have A go to C. This could be 0th, 1st, 2nd, 3rd, 1/2. You know, you don't know unless I give you some piece of data. And then you do this type of thing with it. Yeah.
Could you do an example of one of the cell questions, like the ones in homework 9?
Sure.
I wasn't really able to understand that one.
Yeah. So in homework number 9, which one do you want to, which homework problem do you want to do on number 9? Okay. So in the first one, a voltaic cell is comprised of the two half reactions. So in order to make a full cell reaction work, what do you need? You need two half reactions, and so what do those two half reactions have to be? An oxidation and reduction, right? How are these reactions written? They're both reductions, okay? So we have reduction of CD2 plus going plus 2 electrons go to CD solid, and then tin 2 plus 2 electrons goes to tin solid. Which one do we turn into an oxidation? So what, more noble means what? What's that?
More cathodic.
More noble means it wants to be solid, right? So which one is the more noble metal here? Yep, tin. Okay, so this is a reduction cathode. So what do we do with the cadmium reaction? Flip it around. Oxidation. Okay, so we got that. Now we look up. So where do we get this information from? Noble metal table. Yeah. So now we look up the half cell potentials for this, and we get cadmium. Let's see. We have this cadmium. Okay. So what's the half cell potential that we write right here? Positive 0.403 volts. And we've got the tin one. Yeah.
That's kind of where I have a problem. In the table, it said, I think it was positive, if I'm not wrong.
So let's look at the
Let's
table. Let's see. We want cadmium metal going to cadmium 2 plus. So we look up cadmium metal going to cadmium 2 plus.
So the signs change.
Signs change, right? We have the reverse reaction, and that's exactly what we have right here. And so for tin, if we look on this table, we have tin 2 plus going to tin solid, tin 2 plus going to tin solid. What do we write here? Negative 0.136 volts. What do we do?
Add them up.
Add them up. Whatever that is. So we just sum them up and we get that. Or we can use this formula. E0 cell is E0 reduction of the cathode minus E0 reduction of the anode. So we change the sign and we subtract them and we get the same result. So it's easier for me to use the adding method. You just add the oxidation, you add the reduction, and you get the cell. No problem. You can look at this formula because this is a reduction potential of the anode, so you actually have to flip this back. But then you get the same answer. Yeah.
This is positive, then the delta G would be negative.
Yeah, so the delta G for this reaction is negative, right? Thermodynamically favorable to dissolve cadmium and precipitate tin. Yeah.
I remember discussing that at some voltage, water will electrolyze.
Mhm.
Or will we have to know that?
No. Was it on your sheet?
No.
Okay. Yeah.
In the homework number 8, we had to find half-life reaction or half-life.
Yeah.
And for half-life, we had to find K.
Yeah.
Do we have to find K using Excel, or we can find it like using our plot?
You can find it using the plot, but I mean that's very complicated, right? Where you have to plot all this stuff out, find the slope, things like that. So in general, on the exam, you won't have Excel on the exam,
Right.
but you'll have to know how to deal with the slope. So I might tell you the slope of the line. I might give you a very easy slope, right? I might tell you that the two data points are 10 and 6, There's one, and I might tell you that the other one is, let's see, 12 and 5. You know, so you should be able to find the slope of this line, right? If I tell you what these 2 points are. So m delta y over delta x. And so depending on what this plot is, you should be able to know what the slope is, et cetera, et cetera. Okay. Thanks. Yep. Anything else?
And that slope would be negative.
Yes.
Yes, because sometimes with the concentration, it's not necessarily negative, but with this.
Well, the concentration of A, I mean, A plus M goes to Z. A will always go down as a function of time.
Okay, so I should always think of it that way.
Yeah.
A will, look at my equation and say A will always go down as a function of time. So that should determine what my, could give me a hint on where my slope goes.
Exactly. Okay, I'll be around on Monday and I will see you on Tuesday.